Hello and welcome to this final video demonstrating this DIY data logging shield on an Arduino Uno. The shield has a micro SD card and a real-time clock so that we can log the time and date when data is logged. In the previous demo, I showed wireless transmission of one Arduino with a radio transceiver sending data every 10 minutes to this server Arduino, recording the time and date when that data was sent. And in this video, I would like to show maybe the beginnings of a sensor network with a second client sending data to the Arduino. And so because if you saw that previous demo, we used the reliable datagram, which uses addresses, then the different units know, if you will, which one to send the data to and which one the data was received from. So in this video, this is the server with an address of 1 with the data logger. This is the first client. And this is going to send temperature data every 10 seconds. So in the previous video, it's every 10 minutes. And with a thermistor voltage divider, in this video, for the purpose of this video, it's going to be every 10 seconds, sending data to the server. And it can do that, and this one knows not to respond because of the different addresses. This will send to address 1, and then this will, along with the address of the sender, of the client, and then this one will save that data with a timestamp, but then also send an acknowledgement back to the address of 2, and so this Arduino will know that the data was received. Okay. In this video, this is our second client with an address of 3, and this one has, similarly to this, it has a voltage divider, but in this case, it's a light-dependent resistor here. So as the light on it changes, then the resistance of this component will change. And so with a 10 kilo ohm resistor, that forms a voltage divider. And that's going to be read on analog pin A0 through this here. But this one is a little bit different in that it also has a button here. So this is pin 2, and it's pulled up internally, so a high voltage. And then this wire connects to the button, and the other side of the button is connected to ground. So when this is pressed, it gives a low signal to pin 2, and that's the signal, button press, for the Arduino to measure the light data from the LDR and then send the LDR data, the analog data, to our server. Okay, and so in the programming, the server will detect which address it's from, either 2 or 3, and it will behave a little bit differently, save the data a little bit differently into its micro SD card. Right? And again, this will send an acknowledgement back. So this is sending at regular intervals, and this is only sending during certain events when the light is pressed. And so this is the beginning of our sort of wireless sensor network. Okay, and this is in the Instructables demo 4. So if you want the code to this, the setup to this, then have a look at the Instructables. The link is in the description, and this will be demo number 4. So let me just show you some of the code. So let's go to the computer. So this first code is very similar to the server code in the previous demo. This is the one that's receiving the data. So I'll go very quickly through most of it. So setting up the RTC and the nRF24L01. Again, our server has an address of 1. This is all the same as before. Okay, starting our real-time clock. And then here, we're in the setup, and we are going to open a file, and it's going to be called log4. So this is the name of our file where we're going to save our new data to for this demo. And then you'll see here, we start our blank line, same as before, but then these are the headers for the different columns. Roll the date, okay, and the time, down to seconds. And then here we have a column called sender. So this is going to be the address that we received the data from. So either to from our thermistor sending Arduino, or 3 from the Arduino with the LDR. And then depending on which address that data is received from, we'll save to either a column for temperature or a column for the light-dependent resistor. Okay, again, this is just a confirmation of this being saved. And so here we are down in the loop. And again, the only thing in the loop is this sort of if loop, if you will. All of this is in that if statement. So if there is data received by the nRF24L01, then this is just an acknowledgement down here of which address and what was sent. Okay, so only for the serial monitor. Here's our data log, a character array, where we're going to save all the data. And then here, this is different. So here, this if statement has from, which is the name of the variable of the address. So if it's from our first client, which has an address of 2, then we're going to create our data log with all of the date and time info as before. But then we have one integer here, which is going to be the address, and then 2 strings. And that will all be entered into our character array called data to log. Okay, and so this last integer is just a 2, which is again our address. So we know who sent the info, the data. And then the actual data received, which is going to be the thermistor data, the temperature. And then this last column is just going to be a blank space, okay? Because we don't have LDR data just received right now. However, if it was sent from our second client with an address of 3, then we're going to do something similar. But in this case, when we save the sort of the sender's address is going to be 3, and then a blank space because we're not receiving temperature data. And then in the last column, now we're going to save the LDR data. Okay, so depending on which address the data was sent from, we're going to structure our data to log string a little bit differently. Okay, so then regardless of which one was formed, we're just going to print it out on the serial monitor just to confirm. We're going to open the file, and then we're going to write to the file. Okay, so very similar to demo number 3. If you want more information about this, then please see that demo. So for our first client, this is all the same, so I won't go through this. The only thing I've changed here is our millis interval. It's 10,000 for 10,000 milliseconds, so we're going to be sending every 10 seconds. Otherwise, everything's the same. We're sending the thermistor data now every 10 seconds. Here, this is our code, our sketch for our second client, the one with the light-dependent resistor, the LDR. Again, if you want these different sketches, go to the Instructables. The link is in the description, and you'll find this one in demo number 4. Okay, but since we're going to be collecting the analog data of the LDR, we have to declare what pin it's on. So we're going to use analog pin A0. So we've done that here. We have a button. We have to tell the Arduino which pin the button is connected to. So we're going to use pin 2, digital pin 2. And then if you know about buttons, there's this phenomenon of button bounce where you press the button once, but it sends multiple signals. So we're just going to account for that. So here we declare this variable last press millis. So we're just going to record when we press the button. And then if there's multiple signals, we want at least 200 milliseconds between signals to count it as a subsequent button press. Okay, so if at least 200 milliseconds has passed, then we're assuming that this is a second intended button press, and that's why we're using these two variables. This next part is very much the same as the previous demo. We're using the reliable datagram client example as our base for our code. So here the Radiohead reliable datagram library as part of the Radiohead library, the Radiohead nRF24 library as part of the Radiohead library. Okay, so we use those. We have to declare our addresses. So this Arduino is the second client, but we have to give it a unique address. So we're using address 3, and we're going to send to our server, and it has an address of 1. Okay. We're going to start or declare an instance of the radio driver of our nRF24L01, and then an instance of the reliable datagram using that driver, and then indicating what is the address of this client. This is a buffer. We're going to use the maximum length for our buffer possible. Here we are down in the setup, again, using the serial monitor for the sake of this demonstration. And if you're setting this up for your troubleshooting, but once you get this set up, you can get rid of all the serial print statements, including this. We're going to use our button, so we need to declare that pin as an input. And we're using our internal pull-up on the Arduino. So this button will, by default, be a high signal. And then, as I mentioned before, when you press the button, it'll give a low signal, so the Arduino will know that the button has been pressed. Here we'll initiate the reliable datagram. If it does not work, then we'll just indicate that the initiation failed. Okay, so here we are down in the loop. The only thing in this loop is this if statement, sort of this long sort of loop statement. Okay, that's the only thing in here. And so what will happen is the Arduino will go through the loop over and over and over again until this is true. And there are two statements here. The first one is about the button. So it'll digital read the button pin, and normally it's high, but if it's low, then the button has been pressed. And we have two and signals here. 2 ampersands means and. This must also be true. So the last press, the time of the last press, plus the delay has to be smaller than the current time, right? Millis is the number of milliseconds since the Arduino last reset. So it's constantly, ticking away in the background. Once the time of the last press, or once it's bigger than the time of the last press, and our delay interval, then we know that this is a separate button press, okay? So the first thing we're going to do is update our last button press variable with the current time. Then we're going to read our analog pin. Okay, this will get the light data from the light dependent resistor. We're going to store that in a new integer called LDR reading. Just to confirm, we're going to send that info out to the serial monitor. And then here we'll prepare the data to be sent through the nRF24L01. Same as the last demo. We create a character array called data and give it a few, or here we're giving it 10 elements of space. And then we have to convert this integer to that character array. So we use this sprintf function with basically 3 arguments where we're going to send the data to, sort of the name of our character array, what kind of data, and then where the data is actually stored in the Arduino. Okay, here there's only one. It's an integer, or it's called LDR reading, but you could have several separated by commas within these 2 quotes. They could be bytes, other strings, like like an integer is just like this one, a long. Okay. The only thing that this will not apparently do is floats. So you have to use a different function. So have a look at the previous demo for that, okay, when we use the LDR data. So now that we've saved all our sensor data into our character array, we're just going to print it out to the serial monitor to confirm, and then we're going to go to the nRF24L01. Okay, we're going to use this send to wait function. We're going to tell it what we want to send, so our character array, how big it is, and then where we're sending it to. Okay, address 1 in this case. Then we wait for a reply. So hopefully the server has received that data, recorded it, and then sends a reply back. So we need to know how much to allocate for, the size of our message back. And again, it's the maximum that we declared above. Okay, we need to have, we need to declare an integer for the address of where we're receiving it from. And then if we wait for our acknowledgement from the server, and that's going to be a message of a certain length, okay? And this is the maximum length, how much time we wait before it times out, okay, waiting for the acknowledgement. And then we need a place to record who sent that message. And then here it's just a confirmation, just sending it out to the serial monitor that we got a reply from this address, which will be address 1, and then what our message was. Okay, and if you remember from the previous demo, it's just an OK that we'll receive from the server. If we send it out and that works, but we don't get a response, we're going to print that to the serial monitor. If we send it out, but that doesn't work, then this is what this means. Send to wait failed. Okay, so it didn't get sent properly. Okay, and then that's the end of that if statement. Okay, so let's show this now. This here is from 9-volt power adapter, okay, plugged into the outlet. So now this should be sending every 10 seconds. This is here actually plugged into my computer. So this is a mini USB that we're going to plug in our Arduino Nano. So it should be starting up, but not actually sending anything because it needs a button press. And then lastly, this is also plugged into the computer. Okay, so this one should be sending every 10 seconds. This one will be sending whenever we press, whenever we press the button. So let's go to the computer and let me open up some of these. So in Arduino, if you open up individual instances of the Arduino program, then you can open up multiple serial monitors. So this is on COM port 7. This is actually our second client. There's some garbage here because it was doing something when I opened this serial monitor. That's why we get this garbage, but it initialized the nRF24L01 and now it's waiting for a button press. And then if I go to, this is our server, okay, and let's open that serial monitor. So it initialized the nRF24L01. It didn't fail, so you don't see a message there. Initialized the SD card, and now it's ready. This is what the headers that it saved in the card. And then if you remember our first client with an address of 2, it's sending data every 10 seconds. So at 19.37 degrees Celsius right now, April 7th, 6:54 a.m. and 9 seconds. The second, address 2, and then the temperature, and then here is blank because there's no LDR data sent from this Arduino. Okay, so everything is working so far. let's get our, so again, this is our client, second client with an address of 3 with the LDR on it. So let's press a button here. So it actually got to, it did get some bounce there, but it sent 815 and 814. So if we look back here, address 3, 815, 814 with no temperature data and an address of 3. Okay, so every 10 seconds we're getting the temperature data. And then if I press this button, so now we have 809 and it received its OK signal back. That's the acknowledgement. Okay, here's our 809. Okay, now if I cover up our LDR so it's dark and I press it, okay, the number is 324, so significantly less than our 800. Okay, right here, 324. 324 received on our data logger. Okay, if I hold it up closer to the light, there's a light here just off camera. 885, 882, really close to the light, almost touching the light. Okay, 1000. Okay, so I'm just going to show you what's on the card, but because this client is sending every 10 seconds, this server will be opening the file, saving, and then closing. The last thing you want to do is unplug this Arduino while the file's open, because then you lose all your data. So first, let's unplug our first client that's sending every 10 seconds. This one's okay because it's only sending when we're pressing the button. So let's just unplug our server. And then let's take out this micro SD card and let's put it in the computer and have a look. So here we are at the computer. So this is our micro SD card that's been inserted into the computer. And we have a couple of files. This is from the previous demo, and then this is the one that we just did. So I've been playing around with this. So let's see, we're opening Excel. So you can see I was kind of playing around with it. So it's trying to open several times. This is before we started. And then here we are here. So April 7th, 6:54, 9 seconds, right? That was our first signal for this demo from sender to 19.37 degrees Celsius, but there was no LDR data from sender to, okay, the address 2. And then you see every 10 seconds, a new signal was sent with the temperature data. And then when we first pressed the button, we actually did get a bounced signal. So we did get 2 close together. So perhaps we need to increase our debounce delay there. But you can see that we are separating our data by who sent it to our server. Okay, here when we covered up the light, here when we exposed the light. And so you can see our sort of very simple sensor array and data logging is working. All right, so I hope you found that interesting. I hope you found that useful. There's all kinds of things you can do with this kind of data logger. Okay, either directly with sensors connected to it or with something like a radio frequency transceiver like the nRF24L01. Okay, thank you for watching my different demos. If you have any questions or comments or feedback, please leave comments below. Thanks for watching.